Hello everyone, I am Pavan. I am a student of West Godavari Institute of Science and Engineering College. We have done a project titled AI powered fraud detection in financial transactions. Our team members are Korukonda Lakshmi Pavan Kumar, Badam Grishmanth Pavan, Tamade Hema, Dagpati Kusuma, Chintapalli Ramesh Kumar. We done this project under the guidance of K. Krishna sir, our internal guide, and P. Amaravati madam, our head of the department. This index, we mentioned every aspect which we included in this project, like from abstraction to conclusion. When it comes to abstraction, fraud detection in financial transactions is a critical challenge requiring advanced techniques to identify and prevent fraudulent activities in real time. This approach enhances financial security by providing real time fraud prevention and risk mitigation. And this is introduction. Financial fraud has become a growing concern in the digital age, affecting banks, businesses, and individuals worldwide. When it see this research contributes to securing financial transactions and mitigating fraud risks. Existing system. The current fraud detection systems in financial transactions rely on a combination of rule-based systems, ML models, and real-time monitoring to identify suspicious activities. And its drawbacks are high false positives, data dependency. And this is proposed system. A powered fraud detection system will enhance the existing methods by using advanced ML models and DL techniques. And its advantages are high detection accuracy, real-time fraud prevention, reduced false positives. System analysis, software requirements, operating system, Windows family, version, Python 3.9.21, and hardware requirements, processor, Intel i5, speed 2.4 GHz minimum. Actually, it's a clock speed, and RAM 16 GB, hard disk 512 GB, and its project lifecycle, data warehousing, association rules are created, if else patterns are analyzed, authentication by the customer, alert, and transaction is cancelled. It's a use case diagram of a UML diagram actually. This tells entire the project and it class diagram. It tells the attributes, values and API, and it's a sequence diagram. It tells user and system between API making a backend process. This is architecture diagram implementation. Financial transaction database, a large collection of historical transaction data from various sources like credit cards, debit cards, and bank transfers pre-process. It's like transforming and structuring raw transaction data. Data visualization, it visually representing complex data patterns. Data splitting, it the process of dividing data set into training set and testing set. Education of models, supervised learning models, evaluation, evolving fraud patterns, fraud detection to identify potential fraudulent activity before it occurs. This is Anaconda Navigator, and these are the applications on this base platform. So we switching this platform as our platform, like we created project platform, and on that project platform we have the our applications like see the Jupyter notebook. We have that application. Actually, we installed it before, so now we are launching it. See, after this launching, now we are going to see the code. So when it opens and then when goes to music, actually we saved there, and batch 17, actually we are batch 17 guys. So see fraud train dot ipynb with an extension. See this is the code. Now we are go to kernel and running all the cells, because we are running all the cells to get the output. Now we are importing some few libraries to get the code ready. So import pandas as PD. Pandas is a powerful open source Python library primarily used for data manipulation and analysis. And import NumPy as NP. NumPy is a numerical Python. It used to represent arrays values. That one. And import C1 as SNP. So SNP C1 is a Python library built on the top of Matplotlib, offering a high-level interface of creating attractive and informative statistical graphics, and particularly useful for data visualization and exploratory analysis. Now when it comes to sklearn, actually sklearn is a powerful open source python library for machine learning, offering a wide range of algorithms and tools for tasks like classification, regression, clustering, and dimensionality reduction, built on top of numpy, scipy, and matplotlib. So keep that aside and see the data. The data is there, that is from our data set, which we already store lots of historical data to train this model. So this is all about that one. And see df dot describe, it describes the minimum level and maximum level and 50%, 70%, everything about that data set. And see when it making that train and testing, x train, x test, y train, y test. See, we are doing train the data, and later we get the output to by testing the data. See, plot dot figure. See, plot is plot dot figure, and well, it's like the figure name. Okay, the plot we are giving for that figure. And a plot dot title. Title means what we are going to give the title. The title is correlation heat map. Okay, the correlation heat map. And here we have six graphs. Okay, six graphs. And these are actually graphs are having because of that we used matplotlib. uh, Next one, see these are we have several graphs here. We have six graphs, and with these graphs we are explaining our about our project. See the output or the code we write here. And then see the transaction type distribution. And next one, see this is the heat map. Okay, this is the heat map, the correlation heat map. And this one transaction type distribution. See how the count one and count on y axis, type on x axis. Okay, next one transaction amount distribution. Okay, see the transaction amount distribution going top for into bottom. So next one class distribution. See the class distribution and amount distribution by transaction type. These are like regression type models. So because of we get it. And while and point graphs, this one. And next one, this is the correlation so these are the correlation graphs. This is logistic regression. See the logistic regression we have, we're training the model by using logistic regression because it is a supervised learning model. Okay. And next one, see we're training the data in by using the logistic regression. Now we get the output like here. See the macro average and weighted average. So next one, that decision tree. It's like a decision tree is like a tree like structure. Okay, it has nodes. So with that nodes it can give the output for the task which we give that. So next one, see it is also like train the model. So we are using several models to train the uh, data because we want output by different methods. Okay, see the macro average is different from logistic regression to decision tree. Actually the macro average is different from every model because it changed the it is the solution. So it will change by model. Okay, now see the random forest. The random forest is a combination of number of decision trees. Okay, see it is also. So that random forest output has changed. See the macro average is changed. And XGBoost is an advanced ML model. Okay, so with that, we can get accuracy of transactions. Okay, transactions. With that we are giving the XGBoost. Actually XGBoost is like it can give accuracy by ensemble learning. Ensemble learning is like it is nothing but combination of all the models which we used in this program. Okay, so like that. And see lstm is a long short term memory. It is used for time consumption. Okay, time consumption. And see we are using this. It is actually a deep learning technique. So actually in this project we are used deep learning techniques also. So this LSTM is one of them. Okay, next, see, these are how it making output. Okay, next, actually after this it can give the output. See, actually every model, actually I said before, every model has different macro average. So with that macro average we can get the output. So because the output is change, the output will change by model. We switch the model and it will we can have a different output. Okay, I actually it can detect differently, different approach. It has a different approach everything. And MLP is a multi-layer perceptron. It's interconnected nodes. It has interconnected nodes. And see, this macro average is different. And next one, and at last all the models are saved successfully. So when all the models are saved successfully, it means we can have all the models to be useful. Okay, we can use every model to detect our code. So when we goes back to environments and we click on project and see, when we open the terminal and we write the path. Actually we stored our files on a path, yeah, we write a path and see. Actually, we done this project on Python language. It is very used, very easy to write. It has a simple syntax. See, app.py. It has a Python existence. See, we get IP address here. So when we copy the IP address. Okay, we copied it, and now we are going to some website like browser or a Chrome, anything, our wish. Okay, our wish. And we paste there and see. uh, and now we get our application ready. See, we are the fraud detection system. So we change, now we changing the method. Okay, payment method. We have multiple payment options. So cash in, cash out, transfer, and debit, and amount. Okay, we enter, we done 10,000, we send 10,000 to someone, and we have old balance 20,000 and new balance is 0. So what it means, we used a model and it tells fraud detected. Of course a fraud has done to us because we our current balance is 0 from 20,000 after making the payment 10,000. So this is the interface of fraud detection application. Actually we seen it before. Okay, next, see the process of detecting fraud. Okay, and now output of fraud detection. See, at the bottom, fraud detected. Okay, fraud detected at the bottom, we have that. And applications, banking and financial services detects fraudulent transactions in credit card usage and the payments through ATM machines. E-commerce fraud detection identifies fake transactions. Insurance fraud prevention analyzes claim patterns to detect false insurance. And future scope, logistic regression works well when the data is linearly separable but struggles with complex decision boundaries. When it comes to conclusion, this case study is mainly tells about frauds in financial transactions and what makes them to detect and control the frauds. See, we have fundamentals like planning, collaboration, and security measures. So, like that, we done this project, AI powered fraud detection in financial transactions. Thank you.